Welcome to another video on our YouTube channel Economics to Go. In this video we will go through the solutions to the third and final exercise on our second assignment in the course Competition Policy and Strategy. In this exercise we are now looking at the Bertrand competition. The previous exercises were looking at first Nash equilibrium in general, and then we are looking at the Cournot competition, which is another alternative model to understand oligopolies. So Bertrand competition now is our second approach on modeling oligopolistic markets. And as we will see in the following, the results couldn't be more different. So in this exercise, we are faced with a situation in which there is two firms in a market that is by assumption characterized by Bertrand competition. We have a demand function that reads quantity as a function of price equals 110 minus price. And then we know that both firms have costs of production which are equal to constant marginal costs that take a value of C equal to 10. Right? So there is again constant marginal costs. In this case, lower C takes a value of 10. Now in this first exercise, in this first task of this exercise, we are asked to identify or to name and discuss the differences between the Bertrand competition model and the Cournot competition model. Again, just as a reminder, I would like to refer you to the previous video where we were covering Cournot competition in case you have not yet watched it. Okay, now what are the differences between these two models? Well, the most and more decisive difference is that in Bertrand competition, by assumption, firms strategically decide on the price instead of the quantity. So we previously saw that in Cournot competition, firms will decide on the quantity as their strategic parameter. And now in this model, in contrast, so in this Bertrand model, in contrast, firms will choose the price as their strategic variable. All right. In addition, we need one more assumption, and that is firms are not capacity constrained. And we will see in a minute why this assumption is crucial. All the other assumptions are, of course, very similar to Cournot competition. Both are models that we use to understand what happens in markets with few firms, so in oligopolies. So namely, we again assume in this very most simple Bertrand competition setting, we will assume that there is identical firms, n identical firms. In our case, of course, n takes the value of 2. We will, in this very specific and very simple model, assume there is homogeneous goods. We will again, similar to what we had what we saw earlier in Cournot competition, we will for now assume that there is simultaneity, so all firms are making their strategic decision at the same time, simultaneous game. Again, we will assume that this is a one-shot game, so we are only considering what happens if firms are playing one single period, there's only one single decision, then the market outcome realizes, and then it's the end of the world, and there is no second periods. And yeah, again, in this very simple Bertrand competition model, we will, as you saw on the previous slide, again assume that we have a linear demand function. Okay. All of these assumptions are, of course, a matter of specification. In this very simple, very first approach of this model, we will make a lot of these very strict assumptions, but in general, you will see, or we will see throughout this semester, that we can very well consider a situation where there is not homogeneous goods in a Bertrand competition, and the market results will, of course, differ. Okay, and the same is true for simultaneity. The same is true, and this will be particularly interesting once we are looking at the multi-period collusive behavior. The same is true for one-shot games, or rather for dropping the assumption of this being a one-shot game. All right. Now in this in task B, we are asked to describe how firms in a Bertrand competition react to the actions of their competitors. So just that they get a very general and conceptual idea of how firms are assumed to behave in this model. Okay? So we already identified that prices are the strategic variable of the firms. So firms compete by choosing prices, profit maximizing prices. Second, we now need to understand that in the Bertrand competition model with homogeneous goods, it is the first key result that all demand is served by the firm with lower prices. All right? And the key words are firms are choosing prices strategically, and second, we have homogeneous goods so that consumers really don't care from which firm they buy other than for the price they are asked to pay. So they will always all buy from the one firm that is offering the lower price. All demand is served by the firm with lower prices. Okay, and this now, these points in combination then result in a situation that is sketched by the third point. The competing firms, the competitors, compete by undercutting prices until economic profits are zero. So until prices equal marginal costs in our specific case. Right? Because just consider what these two first bullet points, what these two first bullet points imply. Firms will choose prices, they will undercut each other because as soon as they undercut the competitor marginally, they will be able to serve the whole market and sell all their products, and the competitor, of course, that has been undercut is not selling anything. So it's of course profit maximizing to keep undercutting your competitor. You can then anticipate, or firms can then anticipate that they will be undercut as long as there is room for undercutting. Okay, so as long as firms are able to undercut prices, as long as there is a lower price that still yields in profits that are at least zero and non-negative, firms will undercut prices. And this results in a situation where both firms are setting a price that yields in the lowest possible profits, because then they cannot be undercut anymore. All right, so we will see this in a moment, but this logic of these first two bullet points implies that in the end, as a market result, we will see that the price equals marginal costs. All right, let's first think about reaction functions. I already tried to lay out what the reaction function should capture verbally on the previous slide. Right? I already tried to lay out what the profit maximizing strategy is. Let's now make this formal. Make a formal statement on how the reaction functions of both firms have to look like. And yeah, because I already indicated that this reaction function cannot be a well-defined and continuous function, right? Because firms will keep undercutting until they cannot undercut, and then they will just set a constant price equal to marginal cost. So this cannot be a continuously defined function. Instead, we have to look at a stepwise defined function where each of these steps is defined or is defining the reaction function for a particular interval of prices. Let's start going from high prices, because the logic of this model is of course to undercut each other. Let's start looking at the highest possible, the highest imaginable price, and then look at what happens, how does this reaction function change as the price gets lower and lower. All right, so the reaction function, because price is the strategic variable, in this model is called pi I star, so the profit maximizing price of firm I as a function of the price of firm J. Okay, as I promised, let's start with the high prices. What happens for any price of firm J which is even larger than the monopolist's price? Well, we know from analyzing the monopoly in the previous assignment that the monopolist price is the absolute profit maximum in the market. There cannot be a price that yields even larger profits. So, as long as the competing firm J is setting a price that is even larger than the monopolist price, well, then firm I can undercut by setting the monopolist's price. The monopolist price then, by assumption, is lower than firm J's price, so firm I can serve all the demand, and at the same time, ask for the profit maximizing price in the market, the monopolist's price. Alright, so for any price Pj that is larger than the monopolist price, it is profit maximizing for firm I to set the monopolist's price. Okay. Now, this undercutting, of course, continues until the monopolist's price. Now, what happens the moment both firms are setting a price which is at most the monopolist price? So what is happening in this interval of prices below monopolist price and above marginal costs? Again, going from high prices to low prices. So what is happening in this second interval of prices, of feasible prices? Well, for any price of firm J, of the competitors' firms, that is at most the monopolist price, it is profit maximizing for firm I to slightly undercut and thereby draw the whole demand and to serve the whole demand. Okay, and now we're in this let's say maybe standard or most thought of scenario which I already sketched on the previous slide. Right? For any price that firm J is setting in this interval, it's always profitable for firm I to undercut. And the same, of course, if we switch I and J as indices. All right? So it's always profitable to slightly undercut, set a price that is lower by some marginal amount epsilon. As soon as we set this marginally lower price, of course, the whole demand is served by the undercutting firm, and thereby the whole profit in the market goes to the undercutting firm, and the other firm that has been undercut has zero profits because it's not selling anything. Okay, that's what's happening in this intermediate interval. And I already indicated on the previous slide as well that this logic, this marginal undercutting logic, can only happen until the price reaches marginal costs, because undercutting the marginal costs would yield negative profits. Just think of this scenario where the price is lower than the marginal cost. Well, that would mean that with every single good you sell, you make a negative margin. So you are losing profits with every single unit you sell. So there is this hard lower bound for the price in this model. And as soon as the prices reach the marginal costs, it's no longer profitable to undercut. It's no longer profitable, or it's as it was before, it cannot be profitable to set a larger price. So the only best reaction that's left, basically, is to set the marginal price as well, the marginal costs as well as price. So that's why we have these three sections, in three sections or three intervals defined stepwise reaction function. Okay, we have now found this the definition of the reaction functions. In the next step, let's have a look at how they would look like. And this is how they would look like. So again, we have on the one axis the price of firm 1 or firm I. On the other axis, we have the price of firm 2 or firm J, however you would like to draw it. And the reaction function of firm 1 is the one I am highlighting right now. So what you will notice is there is a monopolist price indicated over here, and for any price of firm 2 that is larger than the monopolist price, so for the interval that is to the right of this monopolist price, it is profit maximizing for firm 1 to set the monopolist price. That is why the function is just horizontal over here. Okay, that's the upmost interval of the prices that we were just looking at. Now, the intermediate section. For each price of firm 2 in this intermediate interval, it is profit maximizing to slightly undercut this price. So for any price on this horizontal axis, it's profitable to set some price that equals P2 minus epsilon, a slightly lower price, which yields in this downward 45-degree slope, because this is of course always true for both firms and they keep undercutting each other. That's the intermediate interval. Now finally, let's have a look at this lowest, or the last interval of feasible prices, P2, and thereby the first, or the last interval left. The last interval left for the stepwise defined reaction function. What we will see is that for there's the marginal costs at this point, and for any price for firm 2 that is lower than the marginal costs, it is still profit maximizing for firm 1 to set a price equal to the marginal costs right here, which is again why this section now becomes horizontal again, right? And of course this whole story holds for, analogously holds for the other firm again. Just convince yourself that you can switch the numbers of my argument, switch 1 and 2, switch I and j, and the same logic applies. All right. Now, finally, we are asked to actually find price and quantity in market equilibrium. All right, this really does not take a lot of effort, because we know that the only Nash equilibrium, the only situation in which both firms are playing the best answer to the best answer, is this lowest one. All right? Just think of it, if firm J is setting a price larger than P, like the monopolist price, then it's profitable to set the monopolist price. So these firms are not doing the same, right? They are set, by assumption, they are choosing different points. So this is not the best answer to a best answer. In this middle part, in this intermediate part, we have this whole logic of slightly undercutting each other. So again, it's always profitable to undercut by some value epsilon. So this is not the best answer to the best answer. It's not it's not the case that both firms are at the same time choosing their best response to the best response of the other firm. There's only one point in this whole graph where both firms are actually choosing a price in accordance to the reaction function at the same time, and that is that in this last case, so that in which both firms are choosing the marginal costs as their price. So we know that in this very simple model, in this simplest version of a Bertrand competition model, we know that there's only one Nash equilibrium, so there's only one market equilibrium. And in this market equilibrium, both firms choose price at the marginal costs. And in this specific specification, we assumed that lower C, so the marginal cost, equals 10. Okay, so the market equilibrium price is 10. Knowing the market equilibrium price, we can of course calculate what the total quantity in the market will be, the total quantity demanded and sold in the market, because we know the demand function, which was 110 minus price. If the price is 10, then of course the total demand in market equilibrium is 100. Now, how do we know what the quantity sold by each firm is? Because technically we cannot know, all right? We know there's a total quantity of 100, but what tells us which firm is producing how much of this? Well, technically we can't tell, but we can make a very simple and not too harsh assumption that in a case where we have symmetric firms, it's feasible to consider that the market outcome in this situation will be an even split. All right, so we have symmetric firms, symmetric cost functions, etc. Firms are equal on the paper. Well, then it's feasible to assume that they will share the demand, the market demand, in equal parts too. So in this case, in this simple model, we know that the individual firm's market equilibrium quantity will be the total market equilibrium quantity divided by n. And in this case with two firms, in this specific case with two firms, of course, then we know that Q1 star equals Q2 star equals 50.